Okay, it's recording. Okay, so basically, we'll be using a combination of both a dictionary and a doubly linked list in this case.
Okay.
And the reason for using a dictionary along with a doubly linked list is in a doubly linked list, if you want to like search for an element, if that element is like there in like, you know, the end of the linked list, then the worst case to get there is going to be ON.
Okay.
Right? Does that make sense?
Explain, please.
So if there are n elements, if I need to...
So you iterate through all of them, and then if it's the last element, then it is the nth element. So okay.
Exactly. So ON. Best case is O1. But
right.
I want to have my best case, I mean, the case as always O1.
Right.
I don't want to take so much time to go look for that element. So what I'm going to do is I'm going to use a dictionary to hold all the elements with their indexes.
Okay.
What that does is now when I want to look for an element in the cache, I'm going to look in my dictionary. So if it is there in the dictionary, I will know what index it is at in the linked list.
Okay.
So I can directly go to that. It's always going to be an O1 because searching in a dictionary is always O1.
Okay.
And the reason for that is dictionary uses a hashing algorithm. So with that hashing algorithm, searching in a dictionary, the time complexity is always O1.
Okay.
So you get the gist of why a dictionary and a doubly linked list, right?
Yep, you're basically changing your time complexity from off into of one using the dictionary.
Okay, so this is the object for a node, like one of these guys. So now we're going to define the LRU cache itself.
One of these guys meaning, is it one of the nodes in the linked list? Is that what you're saying?
Any of these nodes.
Okay.
If I want to create a node in the linked list, I'm going to use, that
So
node will have properties.
K and V, which is key and value respectively.
Yeah.
And okay, you've initialized the self previous and self next to none.
Yeah.
Okay. So as in when you keep adding values to it, it will start accumulating. You will make your linked list like that.
No, like for example, so if I want to create 7, I'm going to say N1 is equal to node of, so node is this guy, of 1 comma 7. So 1 is just like key. I'm saying first element of the linked list is N1. So value is 7.
So in here, doesn't it work from like 0 to n-1, or how does it work? I mean,
this thing range is always from 0. But when I'm storing a key in a dictionary, I don't need to put 0. I can put 1, right? Because that's my indexing.
Okay.
So when you want to make a connection, like I'll just give you an example for this
Point
part.
the previous and next to...
Yeah, so N1's next. So I'm going to create N2 also, which is 2 and 1, this 1. So N1.next will be N2.
Right.
Okay. And
N2.previous
is N1. So
but N1.previous, doesn't it have to be initialized to none, or automatically?
It's already none, right?
Okay.
By default, it's already none.
Right, yeah, fine.
So N2's previous I've done, it's not none now. N2, so N2's next, when N3 comes, I can do it.
Right, okay.
So that's the basic gist of it. So LRU cache.
So in the similar fashion, instead of just having a previous self.previous, value thesis, I mean, sorry, Sudarshan. If you take out that one value, Sudarshan is not there.
Oh God, I was on mute. I'm here.
Okay, all right. So no, for a split second I spoke in Telugu, so I just apologize. But yeah, so if for this node, if you remove the self previous wala, what do you call this? A construct? No.
Yeah, you can say a constructor.
Okay. So if you remove that constructor, then you can basically create a linked list, right?
This is a linked
that
list.
Logic. No, this is a double linked list. I'm talking about single linked list you can create.
Oh yeah, if you remove previous, it's a single
previous, then
list.
it becomes a single list. Okay, yeah.
Okay. So over here, self dot. I'm gonna put capacity here. Okay.
So initializing the size of the cache.
Yeah.
Okay.
Self dot capacity. So I'll initialize my dictionary over here. So dict is an inbuilt thing in Python. Yeah. So I could use this. I could use this, or I could use this. Anything. But I'll do this. So now I'm creating my head and my tail.
Okay.
DJ, you can stop me if you have any questions.
No, I'm listening.
Cool. So head is going to be node of 0, 0. Tail is going to be node of 0, 0. So basically what I'm doing is I'm creating a head and I'm creating a tail. So think of them as head and tail. So the key is 0 and the value is 0 initially. And tail is key is 0 and the value is 0. Okay. So now I'm going to make a connection between the head and the tail such that head and tail, there is a forward link from head to tail and there's a backward link from tail to head. And after that, all the other nodes will come in between head and tail.
Can you repeat that one?
So once you, see.
You've created your head and tail. Or you've initialized it to 0 and 0 basically.
For now, I've done only this part and this part where I've created a head and a tail node. Next, I'm going to create this wiring.
Link, basically.
This link. These two links that So to do that, you'll do, so wait, self dot head dot next self dot tail. Okay. And self dot tail dot previous is self dot head. That's it. Simple as that. So now I've created a head and a tail as two different nodes, which are this node. Node is this node. And between the two instances of this node that I've built as head and tail, I've made a wiring like this.
Right.
Okay. Now that gives you that we basically have built the skeleton of the LRU cache. Now we will put in the methods or the functions which will help us add an element to this cache or remove an element from the cache. And yeah, basically to get, to set, to remove, and to add. Okay. So first we'll do the def get. So you'll be self from a key. So first, what you're going to do is you're going to so you're trying to get something from the cache. Like think of it. You have a cache with 5 elements. Okay. You want to get maybe you want to check if it has the element 3 in it or not.
Okay.
So if it is there, you want to retrieve that from the cache. If it is not there, then it's a different thing. Okay. So first you're going to check if key is present in the dictionary. Okay. So if it is present, I'm going to say n is equal to, n is just a variable that I'm declaring now. Self.dictionary of key. So dictionary of key gives the value.
Right. So n
So
will basically get the value out of that.
yes. So just to give you a small understanding, I guess Sudarshan would not know this. So this is a dictionary, okay? Gigi, are you listening?
Yeah, I'm listening.
So this is a dictionary called, let's say it's the DIC, okay?
May I interrupt?
What?
Okay, I'm sorry, I'm interrupting. So
Uh,
here's the question. Why would you look for the key of the, I mean, yes, you need the key, but shouldn't you be checking if the value exists in the dictionary and then get the key of that? Isn't it the other way around? I mean, just checking.
why would I ever want to get the get the key? The key is a placeholder. I always want,
Okay.
the
No, say
value is
I'm looking.
71382.
So you are first, you'll be given the value, right, to check. So isn't it supposed to be if value in self dictionary, then get me the key of that?
Yeah, correct. That is only what is going to happen. So
But why is it in the code? Why did you write if key is in self dict? Shouldn't be if value is in self dict.
you will see, because I will be using this in another method.
Okay, fine.
Okay. So basically, when I do something like dic of key, this will give me the value.
Right. You were explaining something to Darshan. I mean,
This
finish
part
first.
only.
Okay.
So Darshan, so this part.
Mm-hmm.
So when I want to, in a dictionary, you always have multiple key value pairs. So
Correct.
key value, comma key value, comma key value. So
Give us
if
an
I want,
actual example now. Like 71382 LRR.
okay, so
It'll be easier for
the
you.
key is 1 and the value is 7.
7. Okay.
The key is
2 and 1.
yeah,
Yes.
2 and 1.
So essentially the key is the index of the value and the value is basically the number stored at
Makes
that
sense.
index.
Okay. And then you can retrieve any value by using the right key.
Yes. So
Yes,
basically,
that's right.
let's say let's say I want to put in another element into my dictionary, okay? That will be the fourth element, right?
Mm-hmm.
So if I want to put in a fourth element, how I'm going to do it is I'm going to say dictionary of 4 is equal to 8. If I do this, this happens.
So I remember asking you this. I think the answer is no, but can you also retrieve the key of the value? Like if you say dic of dictionary of,
You
no, you can or cannot?
you can, but the
Okay.
way you're going to do that is going to be a little different. In the for
Okay.
loop, you have to do for key comma value in dic dot items. So items goes through key and value.
Okay.
So then you can get a specific key or the value, but otherwise getting the keys in a dictionary is slightly difficult.
Okay. Fine.
Okay, values is straightforward.
Mm.
So basically I am checking if the key is there in self.dictionary. And if it is, then I'm saying n is the value is that particular, so self.dictionary of that key gives me the value, right? So n has the value. So what I'm going to do first is, if I have it, first I want to remove it, then I want to add it back into the linked list, right? So say that
first you look for it in the cache, and then if it is
yes.
existing, then you take it out of that index and put it in the zeros index.
Yeah, so suppose it was, so it is 7, right? Suppose it is 7. So if I'm getting 7 from the cache, so I want to remove it and I want to put it here. So that's what I'm going to do. So first I'm going to say self dot remove n, okay. Self dot add n, and then I'm going to say return n dot val. Otherwise, if key is not there in self.dictionary, return -1. What is this remove and add? We'll come to it. We'll define them.
Okay.
So that is to get an element from the cache, to set an element now. So suppose it is not there, then you have to put it in the cache, right? Self.key value. So you're going to say if that key is in self.dictionary. Okay. So if it is, then self.remove so you're removing that value from the dictionary. Okay, if it is already there.
Okay.
Take off key, which gives you the value, right? Now you'll say n, you're creating a new node. So by the way, this n and this n are not the same. This n loses scope after this function.
Okay.
So here, these two don't have anything to do with each other. Yeah, so key, comma, value. The key is this guy, and the value is this guy. Okay. So self dot add n. Okay. Add what it is, we'll come to it. And self dot dictionary of key n. Okay. Because n is this thing, right? So self dot dictionary of key is going to be the value of it. So then if length of self.dictionary is greater than self.capacity, okay, then n is equal to self.head.next. Does this make sense?
The length of
What is
dictionary
this
is greater
capacity?
than
So see, the capacity
LRU
is
cache capacity.
only 5 elements can fit into the LRU cache, right?
Oh, yeah, got it.
So what I'm saying is that if the length of my dictionary is more than the capacity,
Makes sense.
then
Okay.
I have to remove an element. So that's what I'm saying. N is the next of the head. Okay, I'm putting a new element, but after putting a new element, I want to remove and delete the last element so that I can stay within the bounds of that capacity.
Okay.
Okay, so after adding the element, I'm going to say self dot remove n, okay, and delete self dot dictionary of n dot key. Okay, so that removes it. So yeah, so set is done. So now we can, the remove and the add things are pretty simple. So remove as from a node. So this is to remove a node. Whatever we've used to remove in everything, like these removes, what that remove is doing, I'm putting it over here. So let's say P is node dot previous. Okay, so I'm saying previous. I'm keeping a pointer for the previous and the next of this node. Okay, are you guys following?
A bit, yeah.
Okay, I think Jayshree is gone. Huh?
No, Ray, I'm here. So I'm just like
Confused?
a little bit. So when you say the length of the dictionary, if it is greater than the capacity, then n is equal to head dot next. Can you explain that part?
So basically what I'm doing over there is, if it is greater than the capacity, I want to add a new node into this thing, linked list.
Okay, right.
So
but you'll have to remove something first, right?
You can do it either way, right? I can put it and then I can remove, or I can remove and I can put.
Yeah,
so I'm just adding it first. And after adding it, I am removing it. And so this remove removes it from the linked list. This delete deletes it from the dictionary.
Okay. So here when you're saying self.head.next, didn't you say that is pointing to the tail?
Yeah, but so that's the thing, right? These are just the helper methods to put a new node and all that stuff. So to put the rest of these things, 7, 9, 8, 1, 3, all these things, we'll have to use these methods after this in the driver code.
Okay.
To actually, build this linked list.
Okay.
Okay. So in the remove, so think of it. If I have 7, 1, 3, 8, 2. Okay. Suppose I want to remove 1.
Right.
So let's say this node, okay, is 1. Okay. 1 is the node. Okay. So I'm saying that P is this node's previous, which is 7. Okay. N is the next. Okay.
Which will be 1 again, right? Or node ka next. Okay, then it will be 3.
Next. Okay.
It will be 3.
So now think about it. If I want to remove 1, okay. This guy is previous.
You basically say node previous is node next is basically n, right? You're linking 7 and 3 instead of having the link between 7 and 1 and 1 and 3.
How will you do that?
You would point the next of P, which is 7, to N, which is 3.
So tell me in code, how will I write it? Here, I have P is node dot previous, N is node dot next. So what will I write here?
Okay. So yes. Okay, fine. Don't I need a reference to the? No, you don't need a reference to the node. Okay. How would you write it? You would. Hang on.
So see, it's pretty simple. My P is node dot previous, right? So P is pointing 7. Here.
Right.
N is node dot next. So N is pointing to 3.
So P is node dot next, which is nothing but N.
Don't go so complex. So P is node dot previous, which is 7. N is node dot next, which is 3. So if I want to connect 7 and 3 and 3 and 7, all I have to do is p dot next, okay, is n.
Is equal to n.
And
And n dot previous is equal to p.
Dot previous is equal to p. That's it. GJ, you followed that?
Yeah, I'm following.
That's pretty simple. So then that's remove, and then def add. So this is to add a new node. Self.node. So I'm going to say over here. So think about it. If I want to add a new node over somewhere here. So adding a new node is always in the beginning, right? So I'm going to say p is going to be self.tail.previous. Okay.
P is equal to self.tail.previous.
So I'm just pointing p to the previous of the tail. Okay. P dot next is going to be node. So whatever is back of the tail,
This is nothing but the head.
Yeah.
And you're saying
So I'm
that
going
is basically the
node. Then I'm going to say self dot tail dot previous is equal to node.
So, okay, here's the question. So when you're saying P is equal to self.tail.previous, then isn't it 8? I mean, if you take it according to the example, wouldn't P be
8? PB? Yeah, it's going to be 8.
Okay, then if you're saying P ka next, which is nothing but 2,
Yeah.
that you're saying is the node.
Yes, I'm adding a node here.
Why are you doing that? Isn't that supposed to be at the head when you're adding a node?
So when it depends on how you want. Okay, so that's a good catch. So if I want to add it now, so now tell me how I would want to do it.
Wouldn't that be P we initialize to self.tail instead of the previous element? And P ka next will be nothing but the head, and that can be initialized to node.
Yeah. So basically, what you're going to do is, this is head, right? 7 is the head. So what I'm going to do is node, okay, dot next, okay, is equal to head, okay. Got it? Node dot previous is anyway null.
Right.
Right. So, so actually actually wait, how we are actually doing this is head and the tail are actually not pointing to 7 and 2. So head is going to be here, tail is going to be here. Does this make sense? So head's next is going to be 7.
Okay.
Tail's previous is going to be 2.
Right. Tail's next is going to be none.
Yeah, tails next is going to be none. So to implement that, so if I want to put the new node after head, so I'm going to say
should be head ka previous, head ka next
is equal to node. Okay. So node dot previous is head. Okay. Head. Okay. And node dot next. That's it. So head dot next is node, and node dot previous is head. So I've added after this over here.
The element at the head, near the head, the first
exactly.
element.
Yeah. So
should you add and then remove the last element, or can you do it the other way as well?
The way you want to implement an LRU cache is your wish. So in any programming interview, if you say that I want to remove the last element from this side, and if I want to keep the least recently used at the back this side, you implement it like that. If you want to use it the other way around, where you want to remove it from here and you want to keep the last element here, so everything is on the programmer.
But before removing, we need to make sure the same element is if it's present in some other index or not, right?
So that's the thing. If you actually observe these two functions, okay, they are helper methods. So I'm doing an add and a remove, but these are not actually adding anything or removing anything just out of the blue. The get and the set methods are the ones which are using the remove and add. So if you observe, when I'm getting, first I remove, okay, and then I add.
Correct.
Right? And when I'm setting, if key is there in the dictionary, I'm removing that particular element, okay? And then I create a new node. Then I'm adding it. Then I'm going to basically create a value in the dictionary. So dict.key basically makes is equal to n. So I'm putting that node into the dictionary. Then I'm checking if the length of the dictionary is not yet if it's more than the capacity, then I have to remove the last element and then put in a new element at the head, right?
Okay,
So
okay.
so then I'm going to
Okay, hang on. I'm just going through the set part of it. So first,
Mhm.
if it is present in the dictionary, you're removing the value from there. Then why are you creating a node again here?
because I have to set it, right?
Okay, fine. So you're basically saying, hey, this is a value and this is the key combination of the node. I mean, of the
Yes.
value.
Yes.
And you're saying you add that at a specific key, which is nothing but the.
So okay, the reason why I am doing this part, okay. Uh, these keys over here are like 1, 2, 3, 4, right? These are like our indexes, correct?
Right.
Suppose I have used up, I have deleted 8, but in the dictionary, 8 was associated with the key 4, right?
Right.
So if I remove 8 and I delete the value 8 from my dictionary, I still have a placeholder with 4. Now a new element comes, okay? And I want to use 4 with that. This is still remaining in the dictionary. That's why I'm removing that first. So when I'm setting, first I'm checking if that key is already there in the dictionary. If it is there, then I'm going to remove that key. Okay.
And the value associated with it.
Yeah, this remove removes the key and the value both. Then after that, I'm creating a new node.
Right, with the key value there.
Then I'm adding this thing. Then I'm doing an add function. Then I'm creating a value. An entry into the dictionary.
So here, when you're creating the entry into the dictionary, the key will automatically be 0, right?
It's a new key.
1.
It's a new key.
It's a new key.
Not 0 or 1. I can specify that maybe 6.
Okay.
Right.
You can specify, but in terms of how the LRU cache works, you're supposed to put it in the front of the dictionary, like the list, right? So
correct. So see, that it might sound a little confusing, but 71382, okay? If I put 1, 2, 3, 4 here, this is not determining that this is 1, 2, 3, 4. I can say 5, 0,
okay,
2, whatever. I can say whatever, right?
Right. It is not exactly how list and indices work. It can be
but
anything.
5 still has the value 0. So this over here is supposed to be 7 for us because this is 7, right? So we are saying the key is 5 and the value is 7. But over here in the linked list, it is at 1.
Right.
Right. So if in the driver function, we have to do that properly. We have to put it 1, 7. But if we put it 5 and 7, it'll just confuse us, but it still works.
Right.
right?
Yep.
So yeah, so after that, you're basically building, you're putting an entry into the dictionary. And after putting the entry into the dictionary, you're going to check, before putting it into the linked list, you're going to check if the dictionary has exceeded size. If it has exceeded size, whatever I put into the dictionary just now, I need to remove it. Okay. So, I mean, not what I put in the dictionary just now, the last element. So N is going to be the head.next. And then remove N and delete from the dictionary.
Okay, right.
Okay. Oh wait, this is going to be tail.previous. The last element is what I want to remove, right?
Yes.
Okay.
Right, it will be tail.previous, yeah, according to the way you specify the head and tail.
Yeah, the way we are building this.
Yeah.
Yeah. And so yeah, that is where the remove and add functions are used. Makes sense?
Hey, Prati, when you add some function, add something, right? An element, will the index or the key, will it be auto-generated?
No. Over here, the key is going to be specified by you. Like, remember over here, we did this node of 2,1. This 2 was the key.
Okay.
This 1 was, nothing is auto-generated in programming.
Okay.
Other than the index.
Makes sense. Okay.
So in a linked list, your 0th element or the first element or second element, so that 0, 1, 2, that is the only thing which is auto-generated.
Got it. Okay.
Yeah. So is this clear to both of you guys?
Yep.
Yes.
Yeah, you can practice it later. I mean, this is actually one of the slightly more difficult problems, but a very, very, very common interview question.
Okay. So when they ask you in the interview, what sort of questions will they ask? Like, will they just say implement the LRU cache?
LRU cache. That is the beauty of LRU cache. Yeah.
Okay, from scratch. Okay, this is how you implement it and show it to them.
This is how you implement it and show it to them, exactly.
Okay. So I mean, like how you can do stacks and queues with arrays or lists? Will they say do a LRU cache with something else, or will they just say implement it?
LRU cache is best implemented with a doubly linked list and a dictionary. This strategy cannot be beaten.
Okay.
Because this time and space complexity together when you check. Space complexity, you're kind of using a little more because you're duplicating the space. You're keeping you're maintaining a linked list and you're keeping a dictionary. So you're using double the amount of space. But so it's like you can ask the interviewer, do you want me to be optimal on space or time? So if they say time, you have to compromise on space. If they say space, then you can eliminate the use of a dictionary completely. And every time you have to, like over here, we did something like if key in self.dictionary, right? We don't do that now. Now we're going to check if the value is present in the linked list. And you can't just say if val in linked list. You have to say for I in this thing so while head dot next, okay, if head dot val or if that pointer dot val.
Can you just write that, Nietzsche?
So something like this. So say we have a...
Write it there only, but just comment it out, no? It's easier that way. Just for definitely.
So it's going to be something like this. So let's say we have...
Isn't it at the get part of it? Or is it near the set? Get also will have to do the same thing, right?
Anywhere you have if key in dictionary.
Okay.
Okay, so instead of if key in self.dictionary, so now I don't have a dictionary, so I have to traverse that whole linked list to find
The whole
whether that
linked list
element.
to find, right.
So first I'm going to say ptr, I'm going to make a pointer to head.
Pointer. Okay.
So while ptr.next, okay, so that's, I'm doing that because I want to say that I haven't reached the end yet. If pt so over here instead of key it will be value now. I don't have any key now. Okay.
Right, yeah.
Because it's a linked list. I don't need values anymore. So if ptr.val is equal to val, okay. Just to make it a little more, little less confusing, I'll say value. Okay. This is this thing, val. And this is the value which you're passing in over here instead of key. So if it is value, then this thing, you can say, you can perform whatever operation you want on that. And come
basically self remove, add, you do the, basically use the helper methods and then remove it and add it into the link.
Exactly. Yeah.
Okay.
And so you're going to do this. So while if ptr.val is equal to value, then do blah. Okay. So do whatever the hell you want to do. Else, so you do it and
if it's not equal to the value, then
you do ptr dot ptr is equal to ptr dot next. So I'm moving the pointer one next. And then we'll go back to while and we'll check ptr dot.
And it is checking the next value, next part, okay, in the linked list. Okay.
Yeah. So if they say, I don't need, I want you to use the least amount of space, do this. If they say, I want you to use the least amount of time, do the other one.
You will do the other one. Okay. Time complexity of.
Yeah. Makes sense, right?
Yep.
GJ, was this too much?
I'm just trying to absorb.
Yeah, this is actually for like one of the first programs to do. This is like actually very complicated.
Yeah.
Is this one of the first programs you're doing, DJ?
Yeah. So Sudarshan is a program manager. So he is program and product and all that stuff. Yeah. So GJ, you can introduce yourself in a better way.
Yeah, I mean, what you said is right. Now I want to really get in deep with programming. And Paddy is helping me with this.
How did you end up becoming a program manager? Did you do the master's the same way?
Yeah, mine was in more of engineering management.
Oh, okay. Okay. Makes sense.
So he basically did all the cool stuff.
Yeah, exactly. And now he wants to get dirty with coding. Okay.
Yeah. Jayashree is the opposite. She wishes she was a program manager.
Oh, okay.
I don't wish for it, but I don't know.
You would prefer that.
Maybe. But sometimes programming is interesting. As long as you don't have a knife held at you and saying, okay, you have to finish this, otherwise it doesn't work.
Programming is always interesting.
Totally.
Yeah.
But how do you remember all this? As in, if you have 20 minutes to solve this, right?
Mm-hmm.
Yeah.
You practiced it so much that you know what are the steps, because you can't sit and think.
Think about it, yeah.
So that's the thing, right? After a certain amount of practice, you'll get to a phase where you, in general, so it's like, the thing is a doubly linked list, okay? This part that we did, in programming, linked lists is one of the most easy concepts to learn. So the part which is a little difficult for a lot of people is this part. Creating classes and objects and all that stuff, and trying to visualize how an object is put into place and stuff like that. If you tell them to just create a linked list, they'll do it without all this class and all that stuff. But your code does not become modular, and that is one of the main things even the interviews are looking at, saying that is it modular code or not? Because if I'm going to sit and make like rewrite the code 100 times for 100 different nodes, that doesn't make sense, right?
Correct. Yeah.
Yeah. So in this case, if I do something like this, the beauty of this code, if you see, is this node is being used in this class, right? So like, for example, over here. So when I'm saying self.head is node, this node is nothing but this node, right? And if I want to do any operation on one of these nodes, initially, I just have a head and a tail. So
Right.
if I want to add a new node like 7 into the thing, I'll say set. I'll just do something like this thing, n1 dot n1 dot set, and I'll have key comma value. So something like n1 dot set, and I'm going to put the key and values. So 1 and 7. It will go and do all this stuff in this.
Okay.
To basically put that in the right place over here.
Got it.
Yeah. So you see what's happening, right?
Right. So initially what you were telling was more like a straight way of doing it now, and then you build a modular code.
Exactly. Yeah. So the whole point is that you need to be able to perform simple operations like so if you want to get something, if you want to set something, if you want to remove something, if you want to add something, those are the main things that you're doing in this particular array of elements, right? All you're doing is whatever I told you in words that you have to take it out from here, put it here, or blah blah blah. This is the this thing, programming representation of that thing.
Makes sense.
Yeah.
So this is a good learning.
Yep. Jay, you wanted to do something else?
Yeah. Yes, sir.
DJ, you still have capacity left?
No, Prairie. I'll have a meeting at 7 in the morning, so
I thought so.
I'll drop. I'll join you tomorrow.
Yeah. Cool.
All
Sounds
right.
good.
Okay.
Bye. Good
See
night.
you, Jim. Bye, Prairie.
Bye.
Good night. Thank you.
Night.
That's okay. Bye.
Doubly linked list theme from my cover item. So can we do hash map and hash set?
Hash map and
Hash set.
hash set.
I don't know, hash map maybe. Shweta told me hash map and hash set. After that,
I don't know what a hash set is.
Okay, hash map. And
hash map is a dictionary.
Hash map is a dictionary, and like, what if I have to implement a hash map? What do I do?
You have to implement a hash map. Dude, is this a software engineering position?
This is a software engineer and test position.
Implement hash map for a test position? I doubt they'll ask.
Okay, fine. Leave hash map for now. Can we please do binary tree and some sorting techniques, please?
Binary tree. Binary tree is a topic which is going to take quite some time. Because in binary trees, you have, so see.
Child and all that, no?
Yeah, I mean, the data structure is fine, but you have a lot of topics to cover in binary tree. So, like, you have like 1, 2, 3.
I don't see 1 at all. Okay,
4, 5, 6, 7. This is a binary tree, okay?
Okay.
So you have like multiple operations in this where there is a breadth first search where you're going level by level.
Mm-hmm.
Then you have depth first search where you go all the way from 1 to 4 and then go back to 2, go to 5, go to 2, go to 1, go to 3, go to 6, go to 3, go to 7.
Okay. No. Hang on. Wait. Okay. You made your point. Can you do some sorting techniques, please? Because yeah, I think this is going to take some time, and I'll have to like do it around there. So
Yeah.
wait, I will also do one thing. Let me just quickly share. Okay. I can share the screen now.
Mm-hmm.
You cannot share while the other person, the participant is sharing. Can you stop sharing?
I don't think two people can share at the same time.